This is lesson 1 in unit 10. We're going to talk about parabolas today. A parabola is the set of all the points in a plane that are the same distance from the directrix, which is a fixed line, that's this line down here, and from the focus, that's this fixed point that's not on the line. So the distance from the focus to the vertex and the distance from the vertex to the directrix, those should be equally spaced out. That's known as the focal length. So this distance here from the vertex to the directrix is value C, and the distance from the vertex to the focal point is also value C. So this line here is called our directrix. This is our focus point. And any point on the parabola is equally spaced from the focus to the point and from the point to the directrix. Those would have to be equal to define a point on the parabola. We also have our axis of symmetry, which divides the parabola in half equally. And this parabola happens to be sitting on the x-axis. And another interesting feature, let's say you had a point on the parabola over here that passed through the focus point and also was reflected on the parabola over here. This length across here is called the focal width, and some textbooks call it the latus rectum, but that focus width has the property that it's whatever the C value is, we double it, so from side to side the entire distance is 4C wide. Next, we're going to look at some of the formulas for parabolas with a vertical axis of symmetry. So when the vertical axis of symmetry passes through the origin, we say that the formula, standard form, is x squared equals 4cy. And if you solved for y, you would have 1 over 4c times x squared. However, when we move that parabola off of the origin, you have to consider the hk value, which h is the x-coordinate, and k is the y-coordinate, which you should be familiar with from our transformations all through the year. And solving for y, some textbooks ask us to do this, would look like that. A parabola will open up when the C value is positive, and the parabola will open down when the C value is negative. And like we said, this vertex is at the origin, and this vertex is at HK. The focus is our C value. The directrix is y equals the opposite of C, and our axis of symmetry is the y-axis. On our transformed parabola, the focus is at H, and then we have to add the C value to the y, and the directrix is the y value minus the C, and our axis of symmetry passes through the x value of the vertex. If the parabola is rotated on the y-axis, then our function would be y squared equals 4cx, and solving for vertex form, we would have x is 1 over 4cy squared. That parabola would open to the right if our C value is positive, and it would open to the left if our C value was negative. The vertex on this case would still be at the origin. The focus would be the C value, comma 0, and the directrix would be x as the opposite of C, and the axis of symmetry would be the x-axis. And we'll see a few of those. If we translated that graph to an HK value where the vertex is at HK, that formula would follow the model y minus k quantity squared equals 4c times x minus h quantity. And isolating for y, we would have 1 over 4c times y minus k quantity squared plus the h value. The openings would still be the same, right if c was positive and left if c was negative. The focus, we would add the c value to the x coordinate, and the directrix, we would have the x coordinate minus the c value, and the axis of symmetry would be the y value. So let's take a look at some of these. We'll start off with an easy one. X squared equals 8y. So solving for vertex form, we have y equals 1/8 x squared. Now this value, our c value, so 4c equals 8, our c value is 2. So if c is 2, that's positive, then our parabola is going to be an upward facing parabola in this case. The vertex is at the origin, and the focus is 2 units up. I wrote the vertex as the focus. So the vertex is at the origin, the focus is 0, 2, and y equals -2 is our directrix. So we knew that the vertex was at 0, 0, and that c was positive, so it's got to protect the focus 2 units up. And then in red, 2 units down would be the opposite direction for the directrix, because we said the distance here and the distance here had to be the same. So they're both 2 units away from the vertex. And then the lattice rectum, or the focal width, has to be 8 wide. That 4c is 8, which means we want to go 4 units from the focus to the right and 4 units from the focus to the left. And there's going to be a point on the parabola that passes through the focus on that imaginary line called the focal width, and also passes through our vertex. So we've got our parabola. It protects the parabolic shape, protects the focus at 0, 2, and y equals -2 is our directrix. That's equally spaced between the vertex and the focus and the directrix. Example 2, we want to find the vertex, the focus, and the directrix for a parabola that is y equals x squared over 4. So we could rewrite that to think about that as y equals 1 over 4 x squared, and that's our 4c. So if 4c is 4, then c is 1. And we know that we have the focus and the vertex and the directrix. They're in that order. So if the vertex is here, the focus is 1 unit up and the directrix is 1 unit down. So we would add 1 and subtract 1. In this case, our vertex is at the origin, and our focus would be 1 unit up from the vertex, so adding to the y value, and the directrix would be y equals 1 unit down, so y is -1, which gives us the focus, the vertex, and the directrix for our parabola. In example 3, we want to write an equation of a parabola with the vertex at the origin and the focus at 0, -1, and we want to sketch that parabola. So we know the c value is -1 and the hk value is 0, 0. So we're following the model for x squared equals 4cy. So we need to figure out 4c. So if our 4c is -1, then our x squared is -4y. So we know the equation for our parabola, and if 4c is the length, or 4 is the length of the focal width, then we need to go 2 units to the right and 2 units to the left. That's in line with our focus point. So our parabola is going to go upside down. It's going to open down. And we have the shape of the parabola with 2 points on the parabola, one at -2, -1, and one at +2, -1. Didn't mean to erase that. And then our directrix would be 1 up from the vertex, so at y equals 1. This is our directrix, y equals 1. So y equals 1 is the directrix. The vertex is at the origin, and 0, -1 is our focal point. And this is the equation for our parabola. Let's look at example 4. We want to write an equation of the parabola with the vertex at the origin and the directrix at x equals -2. So this is our directrix. It's a vertical line. That tells us that our model is going to be x equals a y squared. So we have x equals 4c y squared, or 4cx equals y squared. So graphing our given values, we know that c is 2 because the distance from the vertex at the origin to the dotted line, -2, this distance is 2. That puts the focus over here at 2, 0. So we know the focal point is at 2, 0. And we know 2c equals 4. And at the focus, if we go up 4 and down 4, we would have the shape of our parabola. So a point is going to be at 2, 4, and another point is going to be at 2, -4, and our parabola is going to open to the right, a nice smooth curve. Let me erase some of this so we don't need this. And we know that the equation for our parabola is going to be, since c is 2, then we know our equation is 8y squared. So we can find our equation because we know that 4 times 2 is our 4c value, 8. This is our focal width. And we went 4 up and 4 down to get the other points to draw the parabola. And we know now that our equation is x equals 8y squared. X is 8y squared. And we've written that equation for our parabola. Now in example 5, we want to find the vertex, the focus, and the directrix for the parabola of -2x equals y squared. So following our model, we're going to see that 4c is -2, so c is -1/2. And when the equation is in this shape, we've got a parabola that's going to open to the left because c is negative. And we've got a parabola that opens left. And we know that the distance, or the main points, if the vertex is in the middle, and that happens at the origin, since we don't have an hk value, and the parabola is going to open to the left like this, then the directrix has to be to the right, and the focus has to be to the left. And it's got to be 1/2 because that's our c value. So if we go to the right, we're adding 1/2. So x equals 1/2 is the directrix. The vertex is at the origin. And the focus is 1/2 away. So if we're at the origin, that's -1/2, 0. So our focus is at -1/2, 0. This is the end of the lesson for day 1. Join me back here again tomorrow for the remainder of the lesson.